arc length, before we start and get to formula, I just want to show you what arc length is talking about. Arc length, like if it says, this one says find the arc length of LM. This piece right here. What is this right here? Like we're looking for the piece around. What is that called? It's circumference. So if I want just a portion of it, what do you think I'm going to do? Multiply by either the percent or, what did we do yesterday when we did sector area? Yes, 60 divided by 360 because there's 360 degrees in a circle. So our formula is that the arc length is equal to the measure of the angle, so M, over 360, times circumference. So, fraction of the circle times circumference. That's what the area was yesterday. Okay, we're going to open this up and look at this. I've got some people that are writing double, so I'm going to slow down a minute. I'm telling you, I wrote the words out because if you're anything like me, I have a really hard time memorizing stuff. Always have. So if I just remember it's a fraction times the circumference, I don't have to think about a formula. I just have to think about fraction times circumference or fraction times area. Okay, so let's open that and actually do this example here. I want to find the length of LM, meaning this arc length right here. Okay, I've got 60 over 360 times 2 pi, the radius is 3. Find out what 60 divided by 360 times 2 pi times 3 is. Use the pi button, round to the nearest tenth of a foot. 3 point what? It does come out as pi. 3.1 feet. All right. Number 2, we're probably going to need to draw a clock. So number 2, draw a circle. Number 2, I got a circle. If you don't know how to tell time, it's going to be a problem. I hope you do. A clock, what's at the very top of the clock? And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, it says the minute hand of a clock is 8 inches long. To the nearest tenth of an inch, how far does the tip of the minute hand travel as the time progresses from 12 to 12:45? Yes. Yes, you can. Yes, you can. So if the minute hand is here, and then it ends up here, how did it travel? How far did it travel from here all the way to the 45 mark there? So here was the suggestion. Instead of doing whatever over 360, we just need the fraction. Well, how many total minutes are there in an hour? 60? And how many did this travel? which means you might not even need to draw a clock, times 2 pi 8. You could also do 270 over 360. You could also do 3/4 because it's 3/4 of an hour. Any fraction. That's why we need to stress it's the fraction of the circle. So let's find out what that is. What? 37.7 inches. Notice we don't have squared inches. We're talking about the length now. Most of them are word problems. Alright, now we need to talk about what a concentric circle is. So in the bottom down here, arc length in concentric circles. A concentric circle. You need to put a point or a center. There's a circle. Concentric circles are just circles with the same center. Those two circles are concentric because they have the same center. The radius and the arc length of concentric circles are proportional. Also, it's good to know that all circles are actually similar. Because their sides have to be proportional, don't they? All circles are similar. Yeah. Alright, so we've got concentric circles there. You can have infinite amounts of concentric circles. I could just keep drawing them, but I'm only going to draw 2. Alright, so I'm going to help you draw number 1, and you're going to do it yourself in a minute. 2 arcs of concentric circles are intercepted by the same central angle. We're going to stop there. We're going to draw 2 concentric circles. One, 2, that's terrible, but you know, oh well. Pretend that that's actually a circle. Use your imagination. Alright. It says 2 arcs of concentric circles are intercepted by the same central angle. That means there is one central angle. Of course, these would be congruent because, you know, it actually would look like a circle. The resulting arc length of the arc of the larger circle is 16 meters. This arc is 16 meters. I don't know yet. We don't know if it's half. We know it's proportionate, we just don't know if it's half. And the radius of the larger circle is 12. This is 12. The radius of the smaller circle, this, is 7.5, which means it's probably definitely not. It's not half. Yeah. Find the length of the corresponding arc. We want to know what this is. We are going to set up a proportion. Here's how I'm going to do it. Doesn't mean you have to do it this way every time, but I'm going to do arc in a fraction, and I'm going to do radius in a fraction. The arc of the small circle is x. The arc of the large circle is 16. That is proportional to the radius of the small circle over the radius of the large circle. Solve that proportion. Alright, so when you cross multiplied, you should have got 12x equals what? And then you divided by 12, x equals 10 meters. Great. You just got lucky that time. Alright, I'm going to draw the picture. Again, I got 2 concentric circles. That's way better. Okay. The resulting arc length of the arc of the smaller circle is 36 feet. I now have this one, 36. And its radius is 30. The radius of the large circle is 45. I need to find the arc of the larger circle. What did you set up? $45 over. Okay, so it doesn't matter. You could do x over 36. You could do 36 over x. If you did 36 over x, you needed to do 30 over 45. You're still going to get the same thing. 30x equals what? Then divide by 30. 54. That's a large circle. 54 feet. Okay. We have another foldable to go with this lesson, but you need to take this and glue it on page, I think, 130. Yeah, 130. The title for page 130 and 131, it's been a little while since we titled both, is 16.2, arc length and radian measure. Title them both. Let's talk about the definition of a radian. A radian is a unit of angle measure, like degrees. Where the arc is equal to that of the radius. So first we're going to convert from degrees to radians, then radians to degrees. The formulas that we're going to write down, you do not have to memorize because they are on your formula sheet. So 1 degree is equal to pi divided by 180 radians. Remember how I talked about leaving things in terms of pi yesterday? All of these get left in terms of pi. You will have pi in the answer. So once you write that formula down, open this flap. $180 degrees. So I'm literally going to take this and multiply it by pi over 180. If you need to add a 1 underneath, that's fine. When you are multiplying, if you have the same number up top as you do below, what happens with those two? Okay, now, you're used to hearing the word they cancel, and you hear that a lot. And they do go away, but it's not that they're actually canceling. It's that they're dividing. What's 180 divided by 180? 1, which 1 times anything is itself. So, you're right, I just wanted you to realize that. So it's not that they're canceling, it's they become 1. Okay, so that means we just have 1 times pi, which is, and we still had that divide, but pi divided by 1 is pi. Pi radians. We're done. We'll do better. Alright, number 2. Times pi over 180. We're literally simplifying this fraction. What is the 60? Will 60 go into 180? 3 times. That's why he's saying that. So this becomes a 1 and a 3. What is 1 times pi over 3? If you can't reduce fractions in your head, you could do 60 divided by 180. You'll get a decimal, press math, enter, enter. It'll reduce it for you. Do 3 and 4. Alright, number 2b. What is the first thing you do? Negative 5 divided by 2. I actually need a blank first. Because some of you are forgetting to put your blanks on both sides. Okay. Negative 5 over 2 squared. Here's what I mean. Some of you are not writing this down over here. And then you have no idea what goes here and here. If you are, thank you. What is negative 5 divided by 2? What is negative 2.5 squared? 6.25. This number goes in both blanks. $6.25. Okay, now, how do I actually complete the square? Meaning not complete the square, how do I make it into a perfect binomial? X minus 2.5. There's what I mean. If you do not have this, you don't know what goes here. That is equal to, what is negative 1 plus 6.25? Now, I'm ready to do what I did yesterday. What am I going to do? Square root x minus 2.5 equals 2.29. What else? Negative 2.29. Okay? What do I do last? X equals, I think 4.79, add 2.5, so X equals 0.21. Okay. We're going to talk about the last set now. Now tomorrow, you're going to do the homework over this. You don't have homework today. And then Friday, I will talk about the homework, and we'll do a couple more examples just to make sure you understand, okay? Example 3. What's the difference between these and this? It's got a 0 at the end. Do we have a blank? We're going to have to make one. So, the very first step on these is to move over that extra number. X squared minus 4x plus, I'm going to leave a blank now, equals 21 plus blank. I moved over the number. I don't need it there. If you didn't get example 2b, I'll show you in a minute. Once I've moved over the number, I'm doing exactly what I did before. What am I going to put over here as my side work? Okay, negative 4 divided by 2 squared. What is negative 4 divided by 2? Negative 2 squared. What is negative 2 squared? Where does that number go? In the blanks. My number is in the blanks. What do I do? The perfect binomial. So how do I write that? X minus 2 squared equals 25. Where did 25 come from? 21 plus 4. Okay, now what? Square root it. Take the square root, that's better. Alright, x minus 2 equals 5. X minus 2 equals? Now what? So x equals? Add 2. X equals? Negative 3. Do example 3b. What do you need to do on example 3b first? Subtract 5. I'm leaving 3a up there in case you need it, but I'm going to stop in a minute to do. Number 3, multiply by pi over 180. What did that reduce to? Okay, this changes to a 1. This is a 2. So pi over 2 radians. Okay, number 4. Times pi over 180. What does 135 over 180 reduce to? 3/4. You need to write 3 pi over 4. If you wrote 3/4 times pi, it's the same thing. I just rather see it that way. That's what you'll normally see. Okay, that's how you convert from degrees to radians. Now we need to talk about how you go from radians to degrees. There's a practice test question that you'll see before long. We're going to take the practice test right before spring break that has you using radians. You have to convert back and forth. Alright, the formula to go from degrees to radians is 1 degree equals pi over 180 radians. Well, radians to degrees is the reciprocal. 1 radian is equal to 180 over pi degrees. You can just say rad instead, but no, there's not a symbol. Alright, let's open that and do an example with that. So, with the first one, we are going to multiply by 180 over pi. What happens with pi and pi? They divide to give you 1. Okay, then I have to reduce 180 over 18. 110, and that becomes just 10 degrees. Yeah. Pi has to be there so it will divide out. Okay, times 180 over pi. Again, the pi's will divide out to give you 1. This is where it's a little different here. I've got 5 and 180 and 4. So there's a couple things I can do. I can go ahead and reduce 180 and 4, or I can do 5 times 180 and then reduce after that. You get to choose, really. So do you want to reduce